Greetings everyone. What we are looking at now, basically, I want us to look at our positional isomers. What the word positional isomer means, basically. Now, these are going to be those particular molecules which are going to have the same, right? So these are going to be these molecules that are going to have the same molecular formula, right? These will have the same molecular formula. But now what will be basically different here? It is going to be what? It's going to be, yeah, what? It is going to be now the position, right? It's going to be the position of the functional group, right? Altogether, but it's going to be different. What? This is going to be different in the position, right? In the position of the functional group. Altogether, position of the functional group. So basically, what is that is going to be firstly your what? Your positional isomers, right? Position of the functional group. Now, I want us to understand this more intensely. So what we are saying here, for an example, we are saying, if let's say I can give you this, right? Let's say now I give you this first example. Let's say I give you your butane, your right? Your one in. Let's say I give you now your what? Your but two in, or rather, let's start with your but one in altogether. And I give you your but what this is also your but two in. All right. What does this mean? I want us to look at these two things carefully. Now, firstly, your but one in. How can you draw your but one in? Your but one in, basically, it is going to be given by what? It is going to be 1, 2, 3, 4 carbons, right? This is going to be your position, the position of your double bond, because this is part of your alkene, right? This is going to be part of your alkene. Therefore, the position of the double bond, it's going to be found in your first carbon, right? So which means this is going to be given by what? This is going to be drawn like this, right? We are going to draw this in this particular format. Now, I want you to look at the second one now. Sorry about that. Look, I want us to look at these but two in. Now, but two in now, it's going to be same as, again, this is going to be your what? This is going to be still this is still going to be how many carbons? This is going to be 1, 2, 3, 4 carbons, right? But now the position of your double bond that represent your alkene, now it's going to be shifted into the second carbon, right? Which means now this is going to be drawn like this. This is going to be drawn in this particular way, right? This is going to be drawn like this. This is going to be look something like this, right? So now this is going to be how this particular one looks like, right? So as you can see now, the position in which you find your functional group now has been moved from what? From one, or rather from the first carbon to your second carbon. Out again. So that's what we mean when we say positional isomers, right? We are saying now these structural formulas are the same, which means whenever you are writing this, this is still going to be same as what? This is still going to be same as C4. What? This is going to be still the same as C4, and this is going to be H10, right? This is going to be same as C4 H10, isn't it so? This is going to be same as C4H8 rather, right? Because you're having 1, 2, 3, 5, 6, 7, 8, right? And even in this case, this is still going to be written as what? C4H8, right? Now, this is going to be the structural, rather, this is going to be the, your molecular formula. The molecular formulas of these two things are still going to be the same, right? Now, let me just give you something else so that you can see what we are dealing with, right? Now, let's say I give you something else. Let's say now I give you that you are having one chloroputane, right? Let's say now we go to your haloalkane, right? Let's say you are having, firstly, you are having your one chloro, right? This is chloro butane, right? This is going to be chloroputane, right? And I give you that you are also having what? You are having your two chloro, right? Chloro, what? Also butane. I want you to look at these carefully, right? What does this mean? Now, your one chloroputane, basically, it's going to be represented in this way. This is 1, 2, 3, 4, right? Now, which means your chlorine, remember this, it's what this is going to be your haloalkanes, right? These are your haloalkanes. And now your haloalkanes, you are going to find what? You are going to find the halides, right? The halides atoms, right? So which means basically this is going to be same as what? Your chloro, it's going to be situated in here, right? So which means now when you are drawing here, this is going to be your H. You are going to also continue drawing all these like that, right? Let's draw all these here, right? Now this is going to look something like this. Oh, it's okay. Now, can you see? I want you to see something. Can you see that where your position of your chloro now is found in here, right? But now, if let's say we can write what is going to be the structural what is going to be your molecular formula. The molecular formula here, it's going to be C4 H what? This is going to be H9 and your Cl. Oh, it's okay, right? So basically, this is going to be like that. Now, if let's say we write for the second one now. What is going to be the second one? The second one is going to be CC, right? Then this is going to be same as this. Let's just write this nicely, right? This is going to be like this, right? So this is going to be your bonds here, right? This is going to be now your Cl now is going to be bonded in the second carbon, right? So which means now you can still continue and write all these hydrogens here. You're still going to continue to write all these particular hydrogens here, right? And now from here, now I want us to write the structural formula, or rather the molecular formula in C. Your molecular formula is still going to be same as C4, H9, and also Cl, right? But now, can you see that the position of your Cl is moved from the first carbon to your second carbon, but your structure, or rather your molecular formula, remains unchanged altogether. So basically, this is what we mean when we refer to our positional isomers. Hopefully now this makes sense to you, and thank you very much.